Good morning friends. Today we are going to discuss the topic Introduction to Heat Exchangers for GATE Mechanical Engineering course. A heat exchanger is any device that affects the transfer of thermal energy from one fluid to another. In the simplest exchangers, the hot and cold fluids mix directly. More common are those in which the fluids are separated by a wall. This type, called a recuperator, may range from a simple plain wall between two flowing fluids to complex configurations involving multiple passes, fins, or baffles. In this case, conductive and convective heat transfer, and sometimes radiation, principles are required to describe the energy exchange process. Many factors enter into the design of heat exchangers, including thermal analysis, size, weight, structural strength, pressure drop, and cost. Our primary concern in this chapter shall be thermal analysis. Except for structural strength and cost, the remaining factors may be adequately evaluated utilizing the principles of earlier chapters. The ASME code for unfired pressure vessels sets structural design standards, while cost evaluation is obviously an optimization process dependent upon the other design parameters. Now we will discuss different type of heat exchangers. Different type of heat exchangers. Common heat exchangers include the flat plate, shell and tube, and cross-flow types. A double pipe exchanger, the simplest form of the shell and tube type, is shown in Fig. 1. If the fluids both flow in the same direction, as shown, it is referred to as a parallel, FITO type. If they flow in opposite directions, a counter, flow type. Fig. 2 shows a shell and tube exchanger with several tubes, two passes and baffles. In cross-flow heat exchangers, the fluids flow at right angles to each other, as illustrated in Fig. 3. If a fluid can move about freely while passing through the exchanger, the fluid is said to be mixed. Fig. 4 shows a cross-flow type with both fluids unmixed. Here the temperature distribution with distance is skewed because the fluid in a given flow path is subjected to a temperature difference unlike that experienced by the fluid in any other path at the same distance from the inlet. In the next video we will discuss heat transfer calculations. Thank you.